So today we're going to start looking at systems of equations, which are more than one equation that are related to each other. And we're going to look at how to solve a system or find a solution to a system by graphing. So before we get into that though, let's just remind ourselves what exactly a solution to a singular equation means. So let's say I have the equation y equals x minus 7. There are an infinite number of possible solutions to the equation, meaning an infinite number of x and y values that would make this statement true. So for example, if x is 0, y would be negative 7. If x is 10, y would be 3. If x is negative 2, y would be negative 9. Of course, I can't list all of the possible x and y values since they're infinite, so that is why we use a line to represent the equation, because it shows all of the possible solutions. So I could take my points and plug them in on the graph and connect them to form a line. I can also use what I know about slope-intercept form. So I know that the y-intercept would be negative 7, and that the slope is 1, or 1 over 1. So that will help me graph the line for y equals x minus 7. So this line represents all of the possible values so that y is equal to x minus 7. Now, let's say I have another equation. And my other equation is y equals negative 4x plus 3. So if I graph that line using slope-intercept form, my y-intercept is 3, and my slope is negative 4, which is negative 4 over 1. So I can use that to help me graph this line. So the blue line represents all the possible solutions to this equation, and the pink line represents all the possible solutions to this equation. And you'll notice that there's one point on the graph where those two lines are going to cross. That point right there, which is 2, negative 5, is the value, the only value that will make both this equation and that equation true. So it is a solution to both equations. And I can check that by plugging it into the equation and making sure that it works. So for example here, is it true that negative 5 is equal to 2 minus 7? That's y, that's x. Yes, it is. And over here, if I plug in negative 5 for y and 2 for x, that's also true. So this value of x and y makes this equation true. It also makes that equation true. So it's a solution not just to this equation, but also to that equation. So if we think of these two equations together, they're called a system of equations. And this point here is what we call the solution to this system. So it's the solution that makes not only this equation, but also this equation true. And how we can find that on the graph is it's the point where the two lines meet. Because we know that that point makes this line, makes this equation true, and that that point also makes that equation true. All right, so let's say we're given two equations. This would be a system of equations, and we're asked to find the solution to the system. So again, remember that there are infinite solutions to this equation and infinite solutions to this equation, but there's only one solution to this system, meaning one solution that makes both of these true. And we find that on the graph by seeing where the two lines intersect, because that's a value that makes both equations true. So I'm going to use slope-intercept form to graph these two equations. So the purple equation, the y-intercept is negative 1, and the slope is also negative 1. So I'm going to go down 1 over 1. So all those points on the purple line make the equation y equals negative x minus 1 true. Now my second equation is y equals negative 3x plus 9. So my y-intercept is going to be 9. And my slope is going to be negative 3, or negative 3 over 1. All right, so there we have the pink line representing all the solutions to negative 3x plus 9. So if we want the solution to the system, we're looking for the one point that makes both of those equations true, which would be right here. And that point is 5, -6. So we would say the solution to the system is 5, -6. And I can check this by plugging this point into both of those equations to make sure that it works. And the reason we check is because we could have made an error with our graphing, and therefore end up with the wrong solution. So we want to plug that back in just to make sure we've done this correctly. So is -6 equal to -5 minus 1? Yes, because we're taking the opposite of x, or negative x. So that would make that -5 minus 1. That's true. And over here is -6 equal to -3 times 5 plus 9. There's y, there's x. And that's going to be -15 plus 9, which is equal to -6. So I know that this solution is the solution to the system because it works for both equations. Sometimes you may be given a system of equations and asked to determine if a given point is the solution to the system. So for example, here we're being asked, is x equals 4, y equals 18 the solution to the system? Meaning, does it make both equations true? So I'm going to plug the values of x and y into the equations and see if they work. All right, so if I take this equation, that'd be 18 minus 4. Well, that is not equal to 17. So I can see already that this point is not a solution to this system because this line, y minus x equals 17, would not go through the point 4, 18. Let's check the other equation. So here, 18. Okay, so this point does make that equation true, meaning this line would go through that point. So 418 is a solution to this equation, but because this line wouldn't go through 418, it's not a solution to the system of equations. So the answer here would be no, not a solution to the system. Of course, not all of our equations and lines are going to fit nicely on that 10 by 10 grid, especially when we start working with the word problems. So we're going to use Desmos as a tool to help us find the solution to a system. So for example, let's say I want to find the solution to the system of y equals 100 minus 5x and y equals 90 minus 6x. So these are my two equations. The green line will be representing this equation. The black line will be representing this equation. So I'm going to go ahead and hide these so I can focus on the graph. If I want to see them again, I just hit those arrows and they come back out. So you'll notice that our graphs tend to start close to the origin. Obviously, because our y-intercepts were large, we're going to need to zoom out a little bit. So I'm going to zoom out, and I can see that these lines are going to meet up here. So now that I have that area, I can go ahead and zoom back in a little bit and find that exact spot. Now what's nice about Desmos is that if you click on the green line, you'll notice that it already identifies here the point where they meet. So it helps you identify that exact spot. So the solution to this system would be -10, 150. So if we wanted to check that solution, we could take our x and our y values, plug them into both of the equations, and make sure that it makes both of those equations true. So here we go. Is 150 equal to 100 minus 5 times -10? Well, minus, this would be -50. So that's 100 minus -50. That's 100 plus 50. So that's true. So it is a solution to this equation. And then over here is that equivalent. So that would be 90 minus -60, which is 90 plus 60. So it works for that one. So because this point, -10, 150, is a solution to this equation and a solution to that equation, it means both of those lines pass through that point. Therefore, it is the solution to the system. All right, so here's a question. Will any two lines eventually meet? And the answer is yes, unless the lines are parallel. And parallel lines are lines that have the same slope. So for example, let's say we have here y equals 3x, y equals 3x plus 1, and y equals 3x minus 5. So these three equations have the same slope, even though they have different y-intercepts. So because they have the same slope, that means they have the same steepness, which means they're going to run parallel to each other for infinity. So even if I zoom this out, and then let's say I zoom back in when the numbers are higher, you can see that the lines still do not cross because they're still running parallel to each other. However, let's say I make this line 2x plus 1 instead. Those lines will meet. Let's say I make this line 2x minus 7. Parallel lines, they will never meet. However, if I make this something very close to 2, let's say 7/4 x minus 7, you can see that their slopes are similar, but if you zoom out, you can see that eventually those lines will cross each other. So unless the lines are parallel, meaning they have the same slope, they will eventually intersect. All right, so we're going to go through two practice questions now. I would like you to pause the video and try the question yourself and then watch the solution to see if you're correct. And then if there's anything you don't understand, send me an email or a chat before you try the practice document. So the first question is -6, -2 the solution to this system of equations? So does this point make both of those equations true? So pause here and give it a try, and then restart once you have a solution. All right, so here we go. Let's start with this equation. I'm going to take my x and my y value and plug it in. So 2 times x minus y. Being careful with my negatives there, and I want to know if that's equal to -10. So that's -12 minus -2 is +2, which equals -10. So it is a solution to that equation. Now let's check this one. I have the opposite or -6, opposite of -6, sorry, or -6 plus -2, and I want to know if that's equal to 4. That's +6 plus -2, which is equal to 4. So yes, this is a solution to both equations, which means yes, it's also the solution to the whole system of equations because it makes both equations true. This point would be on this line and on that line. All right, second question is to find the solution to this system and check. So for this question and for the assignment, you can use Desmos just to speed the process up. But again, that means you need to make sure you're checking your solution by hand as well. And when we put that equation into Desmos, we get x is 360, y is -280. So let's go ahead and check on that solution. So here, I want to know, is -280 equal to -2/3 of 360 minus 40. So I can use my calculator here to make my life easier. I'm actually going to find 1/3 of 360. And it's 2/3, so I'm going to multiply that by 2. So that's going to be -240 minus 40, which is equal to -280. So that one checks out. And then we'll do the same thing with this one. So is -280 also equal to -3/4 of 360 minus 10. So 1/4 of 360 is 90. So 3 of those would be 270. That's negative 270 minus 10, which would also be equal to negative 280. So I've proven that my solution is the solution to the system because it makes both equations true.